But it looks like John is up next with Ascension Studios, so like Greg will get him going here in a moment.
All right, test, check. Everyone can hear me?
You are good.
Okay.
And then just on the monitor, unless you're running this with no slides, which that's a whole different kind of AR, right?
Yeah, this very metaphysical reality. Hi, I'm John Shulters. I'm with Ascension Studios. It's very exciting to be, I was an attendee last year, and it's very exciting to be up here today presenting and working with all these people. It's really cool to see all these advanced technologies used as a tool set for designers and other sort of producers. It's very cool to see the stuff that is for end users, consumers, marketing, that kind of stuff. But to me, it's really exciting to see the technology leverage in a way that can make sort of designing and visualizing more robust, which is basically what I do at Ascension Studios. We started as a fine art studio, but just with connections with architects and other designers, we started doing design visualization work, 3D animation, some of the standard stuff that was happening in the year 2000, which is a long time ago now, actually. And what I want to show today is look into the pipeline we're developing that is addressing a specific design and construction industry, which is tree houses. And so I'll kind of take you through the different opportunities that were presented to us and some of the solutions we've developed to help in this very kind of unique design space and the issues that were presented here. So this was probably 3 years ago now that we met up with a guy named Pete Nelson, who you may know from his new Animal Planet show, Treehouse Masters. He is known as the Treehouse Guy. He's up in Washington near Seattle and has just built a prolific amount of beautiful tree homes all around the world. And these aren't just sort of the backyard kid tree houses. These can be 4,000 square foot mansions in the trees, and they're very impressive. So it was very cool to work with him in a way that initially was fairly traditional. He would create plans, and I would take them into 3D and visualize them. But as we kind of worked through this industry, which was new for me, we saw some different trends and some different issues that were popping up that I think we could solve with technology. One of them is just in general the tiny home movement. This is just a sample Google image search, and immediately you come up with all of these solutions for tiny homes, which happen to include tree houses. Basically, a tree house is just a sophisticated support structure in a tree that you can build a tiny home upon. And it's that structure in the trees that has also become very advanced, it's been analyzed thoroughly by very capable structural engineers. And so basically you can have these, what are commonly referred to as tabs, treehouse attachment bolts, that connect to the tree in a way that the tree any puncture into a tree is considered a wound, but it will compartmentalize that wound and basically take on this new load as its own. So this false branch becomes, to the tree, a real branch. And so if your tree house is built in this tree and survives the first year, it'll probably survive forever because it has now grown to accompany this new structure. But basically when these guys are out designing, Pete may walk out into the field and he's got his little grid paper notebook, a pencil, and a tape measure. And he stands on the ground and he kind of estimates this and sketches out some things, draws some circles, some lines in between them to get some measurements. And it was fascinating to see all of the work that he has done with this method, since I come from sort of the digital realm, and he's also obviously very analog. And he is successful to a point, mainly based on his experience, but we started to see where this technology might be able to help him and other similar designers in a way that could produce something that's much more accurate. And sort of at this time that we were working together, a lot of these new technologies were emerging that were sort of just broaching into common acceptance and usage. And one of these was photogrammetry, which is, I kind of call it the poor man's LiDAR, so that we can get out in the field and take a series of photographs around any object and then upload these images to the cloud. They process, they create all the positions of the cameras where you took those photographs, and then triangulate all of the pixels of the photos into a 3D model. And just show kind of one example of that. So these are just some of the trees that we've scanned with the photogrammetry method over several years now. So the approach has been refined continually until that eucalyptus tree in the middle is the latest one we've done. And I've got a little bit of some of the props that we use now that we've developed. So this is what we just call the axis for the technologic scanning process that we do. And initially, we would just have some sort of a cardboard box or a construction T-square that would be some sort of reference of measure, so that we could try to get this tree scanned at true scale. That's the most important part of this design process. So it's been refined over the years now, where we just have this little system that's light aluminum 3D printed materials that can fold up and pack in my little toolbox, can easily get on a plane or in a bag, and basically it just unfolds, and you set this out in the scene. It has bubble levels to keep everything straight, compass for north direction, RGB, XYZ. So you set this up in your environment, and once you've got everything leveled and calibrated, you can set this anywhere, perhaps at the bottom of that tree. And now as you take all your pictures, this object is also in all the photographs and can be used inside the software to create. It's basically designed with the software in mind, because you have to create a world axis in the software. You have to create a reference distance. So we designed a physical thing that can be snapped to create that automatically. So almost everything happens in an automated way. So all the photos are processed in the cloud. We can create all of the accurate dimension and orientation of the model, and then bring that into our scene. And sorry, let's just get back here and just show you kind of a little bit of the process. Okay. Sorry, let's get over here. So this is sort of just a glimpse into this system, right? So we have all the photographs at the bottom, and you can see kind of what results from those photographs as we scan them. And now we're bringing these into our 3D design applications, where we can create proxies for those trees if the scans aren't quite accurate. Now they're getting really good. And then we can slice through the trees at any level that the treehouse builder may think he wants to build, which creates these sort of boundary areas between the trees, where he can set out the structure for those trees in a very accurate way. And let's just kind of, these moments are very quickly passing, so let's just make sure we can see everything here. So it's interesting to see some of the other approaches of the designers on this panel also, because we are also trying to leverage not just static photography, but mounting these on aerial vehicles with our GoPros on there, also with some depth cameras, so that we can effectively kind of fly against the tree, painting this tree with light, and in real time getting that model without actually having to do any cloud processing. So that gets us the model. You can bring the model into your 3D software to design it, but there's also some applications for the end user, for the person who's paying for this treehouse, that they want to see something more immersive, because this construction process may be a month long, a month and a half, and they're always anxious to see whatever they can do. So we've tried to figure out all these ways where we can get a quick view from where you will be in the treehouse. Started off with the chrome ball here, which we can kind of prop that up in the tree and get something that is sort of indicates, maybe where that house is in the distance, or the pool, or the tree, or something like that. But obviously very blurry, not that great. Then we can move on to fisheye lenses, get a camera up in the tree and shoot these panoramas and get that view right away. But, sorry, there's also the Gigapan. I'm not sure if people are familiar with the panoramic head. So we can shoot exceptionally high resolution images that we can basically zoom and 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 get really good detail and quality from that view. Likewise, we're also taking that same aerial vehicle to get some good views so that we can fly up in this tree and be able to see off into the distance and be able to get something that's very high quality, very, represents that experience of being up in that tree. And likewise, just, this is with videos and cameras, but we are also kind of taking this into another virtual world, using some of the Unity game engine and the Oculus Rift system. A lot of the these are some just offline renderings of that imagery. But sorry, let's just get back to this presentation here. So some of the images that are rendered, at home on the computer. But where we want to take this is that when we're in the field, operating in front of this tree, which we already have a model of, we want to be able to start designing immediately with those people next to us so that we can create massings in that space, move them around, start planning out our structures ahead of time, and also, using some of that data to create other experiences for the end user. So we, first time we got our 3D printer, what's the first thing we're going to print is a little treehouse. And, open up the lid, pop open, so there's a little tag in there. You've seen how the AR works, but we can see what that finished visualization of the interior is going to be. And basically just kind of push these technologies in a way that help the end user as well as the designer, and we're way out of time, so I'll move on. Thanks. Started off with Autodesk 123D Catch, just free, easy solution, but the same company that makes that technology, AGSoft PhotoScan, is sort of the commercial version that you can use for the photogrammetry.
And is that by Autodesk?
It is not by Autodesk. Autodesk licenses their technology to create 123D Catch, so it's the same environment, same tool set, but it's Autodesk also has Recap, which is sort of their commercial version of Catch. Sure. Since it came out of my office, yeah. Exactly, yeah, this is our little maker project. So it's basically just a way to refine photogrammetry so that we can get a lot more accurate 3D model of this tree so that we not only see it for design, but in theory can then take that into the environment, because tracking a 3D organic environment can be a nightmare. But since we have all the data points of that actual tree, we can occlude the geometry of the tree in the space and have something that's a lot more robust.
Very cool, but I think you don't sell them because I want one.
Well, I'll put your name down on the order list. We'll Kickstarter this thing. Cool.
What about videogrammetry? Have you ever thought of that, where you could model a moving world?
Yeah, to model a moving, well, we can use the video basically as a sequence of stills. So that's kind of how videogrammetry is working right now.
Mesh is not consistent, right, from frame to frame?
It can be. I mean, it can be as accurate as photos, but we'll move on here to the next presenter, and I'll be happy to take a lot more questions afterwards. So thanks.
Awesome. Thanks a lot, John.